Okay, so just to make sure that we're almost staying in schedule, next in line is Richu Healy, and he's working for Stripe in San Francisco, by the way, one of my favorite towns. I always like to be there in San Francisco. And he's talking about a tool called unrubby that is used for reverse engineering without doing reverse engineering, which sounds very promising for me. And without knowing details, I already did some promises to some attendees at the beginning of the week that they don't have to be afraid of obfuscation techniques anymore after visiting your talk. So please, Richard.
Cool. Awesome. Can you all hear me? Yeah, fabulous. All right. Sorry, I can't hear myself in the foldbacks, which is always a little bit dicey. So hi. Thank you so much for having me. My name's Richo. This is the obligatory kind of who is this guy slide. So yeah, I work for a company called Stripe. We do sort of paymentsy things on the internet. The reason I work there is because I used to do defense, and I thought it would be more interesting with billions of dollars involved, which turns out to be roughly the case. I have a CVE in a skateboard. As far as I know, it's the only one in existence. My co-researcher there presented training over the last 2 days. And I also run a conference called Wrong Island Con. So anyway, I'm trying to get in the habit of taking a selfie with every conference that I speak at. So assuming that you're all willing to be in it, I'm going to take one right now, and then we're going to get on with this. Cool. So this talk. So I'm going to talk quite a bit about the intricacies of bytecode VMs. Specifically, I'm going to be talking about Rubby, but nearly everything in this kind of applies to varying degrees to other bytecode VMs. To address the inevitable question of to what extent can this be applied to Java, some but not all. Rubby's dynamism is actually what kind of introduces most of the, not really vulnerabilities, but quirks that I exploit with this technique. I'm going to talk a little bit about kind of reverse engineering from the context of someone who just doesn't like doing reverse engineering and honestly just kind of wants the payoff. And it might be a little bit opaque at times. I have a tendency to speak really, really quickly. I actually have a note on my laptop that says "speak slower, idiot," which I'm going to keep glancing at and trying to remember to slow down a little bit. But if I am kind of talking in some depth about something that's obviously not making sense, please feel free to grab my attention and ask me a question, because it's a lot easier to explain at the time than it is to go back and be like, oh yeah, this will make the second half of the talk make sense during Q&A. The other thing that I want to call out is that I'm going to talk about Rubby a lot. I've worked with Ruby for years, and I've basically lost the ability to take it seriously. And so referring to everything about the Ruby ecosystem as Rubby makes it significantly more tolerable. So when you hear me say Rubby, I'm talking about the programming language that you know as Ruby. And just to kind of expectations set a little bit, this talk isn't really dropping bugs, right? The tool kind of exploits behavior that's strictly necessary of the VM. And so if nothing else, it's not kind of patchable in the same way that a bug is. What I'm presenting is very much a technique and a tool that kind of exercises that technique. So the problem space that I was looking at is that there are companies on the internet who want to give you a piece of software, whether it be kind of an appliance or a tool that you use as an end user. They want to give you some computation, and they're unwilling to have you know how it works, because you will probably then set up a competing company in the next couple of days. Right? And so while they want to give you some computation, they don't want you to be able to scrutinize, inspect, work out how it works, or modify it. And I changed my slides before this talk. So I wanted to quickly touch on some of the words that I'm going to use to hopefully preempt a lot of this. So a VM is a virtual machine. Virtual machine is an overloaded term. It can mean kind of a guest operating system running on your laptop in something like VMware or VirtualBox. That's not what I'm talking about. What I'm talking about is a machine, basically a Turing machine that accepts some operations and kind of performs them in a statically bounded way, and specifically talking about that abstract machine, although there is a concrete implementation of it, and kind of the difference between the virtual machine and its implementation will come up in a second. So the solution that everyone comes up with to this problem is obfuscation, right? And so basically what that means is like they take the source code that their engineers write and they kind of do stuff to it and then give you something that isn't trivially reversible back into that source code. And obfuscation isn't really new. People have been doing it basically since computer programs became a meaningful thing to distribute. And in terms of kind of intentional attempts to make reverse engineering hard, the malware community has been getting really good at this for a really long time. Because the same techniques that make reverse engineering difficult from a human perspective also make efficient categorization of programs to work out whether or not they're malicious difficult. So obfuscation is kind of difficult in a bytecode VM. There are a lot of neat tricks that you can do when you're running directly on the silicon. Things like performance counters that don't really have effective mechanisms to subvert or make lie to you the program. And so you can do things like work out whether or not you're running in a modified environment. In a bytecode VM, it's extremely difficult to do that because you have to trust what the VM tells you. And in this instance, I control the VM, so I can tell you whatever I feel like. And so as someone who was interested in reversing, this was a massive step forward for me. And the dynamism of Ruby makes this even worse. For example, if you're obfuscating Java bytecode, you can take all of the class names and name them class 1 through 1,000,000, right? And you have the tooling to statically do that and guarantee that you've actually fixed all of the call sites. In a Rubby application, you can do things like accept classes from URL parameters and then look up the class by that name. And if you've renamed it from class name to class 1, your application stops working. And so there's a lot of semantic information that you simply can't throw away about the program during your obfuscation step. Again, that makes my life really easy. And finally, because Ruby doesn't have a coherent JIT, you can't do egregious things to the function bodies because they'd be really, really slow. In the presence of a just-in-time compiler, you could kind of undo that damage at runtime. But as it stands, that's not really possible. And so when I started doing this research, I picked up an obfuscated product. At the end of the day, the problem that I had was I had this thing on my desk that I was interested in, and no meaningful way to find out how it worked. So I opened the source, and it was a bunch of basically base64 strings that were getting passed into a loader. And there was this shared object sitting next to it called loader.so. And so I dropped it into Hopper, and Hopper essentially told me to go fuck myself because who is going to reverse a function with 1,400 basic blocks? Not me, is the really short answer to that question. And so I figured it was worth kind of picking out a new approach to this problem. And so, as you're probably familiar, Rubby is an interpreted dynamic language. YARV is yet another Rubby VM. And so YARV is the implementation used by MRI, which stands for Matt's Rubby Interpreter. Now, what all of this is to mean is that MRI is kind of the gold standard Rubby. There are a bunch of implementations of Rubby, but MRI is the one that nearly everything uses. And so the rest of this talk is going to talk kind of about specifics of MRI's implementation, but all of the bytecode tricks are equally applicable to any VM because they're all compatible with the same bytecode. So if you're really, really lazy and you're interested in reverse engineering something, what do? Well, this is basically the operation of Rubby's VM. You have a source file, which gets read in. It passes through Rubby's internal compiler, which then does code gen, right? And so essentially, it's taking source code and translating it into bytecode. And you can even ask the VM to have a look at it. On the right, this is obviously, it doesn't all fit. But this is basically the disassembly that comes from parsing this file. You can also get it to pretty print it as S expressions, which are significantly less useful if you're trying to read it by hand. But the fact that there is kind of a built-in, very convenient representation of this instruction is going to come in handy in a second. So kind of as an aside, and this is probably a great example of why I really struggle to take Rubby seriously whenever I interact with it, bytecode, a bytecode object, which is called an instruction sequence inside of MRI, has a header, which makes a fair bit of sense. It describes things about the bytecode. And the header has a bunch of fields in it, including more than one version field. And so you might naively think that every time they change something incompatibly inside of the bytecode format, you would bump one of these versions. And then when you parse the bytecode string, you would know which version it is, and therefore you'd be able to pick the appropriate parser. Well, that's simply not the case. And so if you do get an arbitrary bytecode string from somewhere, you're basically limited to going back and just kind of like trying everything until one of them doesn't throw exceptions. And that's probably the version that it's targeted at. The fact that someone felt the need to put a to-do above the thing that would prevent the compatibility issues is simply amazing to me. So anyway, once you have your bytecode, you need to evaluate it. And so what this process looks like is basically that bytecode string gets passed into your VM, and in turn it executes every instruction, whether it be a branch that tells it to go and execute an instruction somewhere else, or a store that tells it to interact with memory and what have you. However, in the case of the obfuscated VM, it looks a little different. So at the end of that code gen phase, the bytecode gets passed into an obfuscator, an obfuscation engine, which then kind of mangles the code as best it can, both kind of at the bytecode level, wherein it translates the bytecode into equivalent but much more difficult to read operations, and then it takes that output and kind of mangles that before it writes it out to the disk, which gives you this obfuscated source file. And so at runtime, when you go to run it, you pass this obfuscated source file into the VM, it unpacks it into memory, and then evaluates it. And so this is kind of what it winds up looking like. This actually is just kind of some garbage that I produced for it, because as much as possible I was trying to put not watermarked code into my slides, because I don't particularly feel like being sued. But this is basically what every implementation of this winds up looking like. And so, before you go anywhere, like, Rubbies VM is extremely dynamic. You can do things like attach a debugger and just pop a REPL. And this sort of works. You can get a remarkably long way with this in that you just get, if you've ever used Ruby in production, you've probably interacted with prior, you start a REPL and you just start poking around with objects that exist in that namespace. And you can get a reasonable way towards finding how something works. But if you're interested in doing something holistic, like finding web bugs in an application that spans tens of thousands of classes, kind of spelunking around in a REPL is not an effective way to find out what you want. If nothing else, it depends on remembering where everything is, or at best, maybe writing tooling to enumerate the runtime at runtime. You can also attach a debugger and call rbf-eval directly. rbf-eval is a function that takes strings and evaluates them, and in that way you can execute Ruby code without needing to touch any of Ruby's runtime, which means that the original techniques that people use to try and stop you from doing this are fairly trivially bypassed. However, all of this dynamism makes your life extremely difficult. Without holistic context, it's really difficult to know what you should be going looking for. And unfortunately, the changes that you make to the VM will often trip into anti-tamper mechanisms. However, Ruby is open source, right? So instead of taking the bytecode and trying to reverse engineer the loader format, trying to reverse engineer what they did to it, you just build a malicious Ruby. And so what I did was I took MRI, I took a bunch of the loaders, and I just started adding hooks to the runtime. So every time the runtime did something that I thought might be interesting, I added a hook to just kind of emit that information so I could have a better look at it. And so this is what that winds up looking like. The very first place that I went looking for is iseek eval. So this does more or less what you would expect. It takes an instruction sequence and it evaluates it. And so basically what I do is, every time I get an instruction sequence, I call the disasm method on it, which just disassembles it. That's that view that I showed a little bit earlier, just kind of nicely formatted opcodes with things like operands dereferenced. And then I call standard out and say just like, print this to my terminal. And so what I did was I then booted the application that I was targeting with this modified Ruby, and it emitted all of the bytecode. And so what that did immediately was bypass all of their obfuscation at kind of the file format layer, right? And neatly for me, no matter what they do to that code, this will always work, right? Like, it's a hard constraint that you're able to evaluate Ruby bytecode, because otherwise you wouldn't be able to ship the application. And so immediately this had stripped off like half of the problem, right? And I didn't have to reverse any one of those 1,400 basic blocks in the loader, because they'd done all the hard work for me, right? They just arranged for my code to be called after they've done whatever it is that they're doing. And so rb-eval iseek is really interesting, as you would expect, because it hits all of them. But it's kind of difficult to work with, because it gives you entire program state. The way that Ruby works under the hood is not as you would in, say, an ahead-of-time compiled language, where you take source code, kind of translate that into some intermediate representation, and then emit that to be loaded all at once. When you boot the Ruby VM, you then go through and say, I want to define a class, and I want to define methods on that class. And there's no point at which you have to stop doing those things. You can always modify the runtime state. And so instead of taking the bytecode that says, I'm going to create a class, and looking for that opcode and trying to parse what happens next, you can go back and start instrumenting the specific behaviors that you care about. So rb-define method, for example, means that they'll invoke me every time they define a method on something. And so I no longer have to go fishing through the bytecode looking for method definitions. They'll actually bring them to me. And my personal favorite is that one of the products that I evaluated actually hooks rbf-eval. Their obfuscation engine backs onto it. And so unlike everything else that I reviewed, where I had to reconstruct the source manually, they actually provided me full source code complete with comments, which was a fantastic day for me. Sadly, only one company that I've run into has kind of chosen that strategy, I suppose you would call it. All right, so now we have bytecode. And we can trivially unwrap the bytecode for loaders that we run into without even attempting to look at the loader. Which kind of, as an aside, is a little bit semantically interesting, because I have no idea if I violated their ULIs, right? Like I said I wouldn't reverse engineer their loader, and largely I didn't. I just kind of like let it give me the code, and I still have no idea how it works. Well, so what do you do next? So under the hood, Rubby is a stack machine. It has a couple of basic registers, but logically, nearly every operation operates on a stack. And so, aside from having PC, a condition register, and a return register, everything kind of either pushes to, pops from, or interacts with the stack. And so you can take kind of YARV bytecode and inspect it directly. And if you strip away kind of the instructions that aren't obviously necessary in this, so everything to do with the cache you can safely discard. Obviously, this is just kind of an optimization. The jump label is not important because this code doesn't make any jumps. But it's actually reasonably readable. Like as a human being, you can read through this and roughly work out what you would translate this back into in source, right? I load the math constant. I send a simple method to it called square root. I dupe the original variable because Rubby has this neat property where whatever you do, you always leave the last result on the stack. And so what it's doing is it's duplicating this result so that it can both store it in the A instance variable as well as in the return register for whatever this returns to. And then it leaves the frame. It's pretty simple. And that's really cool, right? Like the fact that it's expressive and easy to read is great, as long as it's actually generated by the compiler. For better or for worse, like not all bytecode is emitted directly by the compiler. And as I mentioned, nearly all of these companies go out of their way to try and mangle the bytecode a bit more before they hand it over to you. And so I started writing a decompiler, and that seemed like a pretty tenable solution. But kind of a couple days in, I figured that maybe I wasn't the first person to try and tackle this part of the problem. And so I started looking around. And so there's a project called Reversal, which was written by Michael Edgar at Dartmouth, which will basically take a bytecode sequence and attempt to turn it back into its original source. This actually works kind of similar to Pyretic, which was a Rich Smith project to do something similar to Python, except that it operated entirely statically. It was only interested in looking at compiled bytecode files on disk and it wasn't able to do any kind of behavioral analysis of a running VM. And so Reversal is quite cool. Unfortunately, if you look through like the Ruby source itself, there are tons of places where it just simply doesn't compile anymore. As open source projects go, it's actually extremely hostile in terms of trying to work out what's going on inside of it, because there's a ton of kind of overloaded names. There's a section in the README where they actually say that they co-opted an opcode and renamed it, wherein they took one opcode, renamed it over an existing opcode, and threw away the old definition of the old one, which means between those two definitions of the VM, you actually have no idea what this instruction will actually do without invoking it and having a look at the world afterwards. There are also a bunch of debug flags that simply break Ruby, which is really interesting when you're doing something like this and you actually want all of the debugging options that you can get. And finally, the VM has added a bunch more instructions since Reversal was written in 2010. Unfortunately, very few loaders actually support that far back. And so there was kind of a bunch of extra work involved in getting Reversal back into a state where it would work. It's also kind of a fun aside that I found. There's a bunch of these where kind of working on the VM, I just found neat things buried in it. For reasons that are a little opaque to me, there's an instruction called bitblt. And when you invoke this instruction, it creates the string a bit of bacon, lettuce, and tomato and places it onto the stack for you. And this is kind of a neat Easter egg in the language, I guess. But I'm so frustrated that if you actually kind of in Ruby code try to create this string and do something with it, the optimizer doesn't know about this instruction, and so it's never actually exercised, which I think is a bug that someone should fix fairly immediately. Kind of a second aside is that Yukihiro Matsumoto, the guy who wrote Rubby, is Japanese. And in spite of the fact that the official policy of the Rubby project is that Rubby code is written in English, the Rubby source code is still largely Japanese. And so when you're trying to work out exactly what some opcode does, you might go through and read the documentation. And the English documentation says expand array to num objects. I don't speak Japanese, but I'm willing to bet that all of this translates to more words than expand array to num objects. I got fairly lucky in that some of my friends are actually learning Japanese, and so they were actually quite willing to kind of take me posting random questions and saying, hey, I found these like 6 characters. I think they're in some way relevant to this like bizarre corner of the VM that I'm currently looking at. But it made it extremely difficult to get into the VM when all of the documentation was either incomplete, outright lying, or just non-existent in the only language that I speak. And so I went through and spent quite a bit of time on Reversal, I added support for Rubby 193 and then subsequently for Rubby 2.1, which is kind of not actually the current one anymore. 2.2 came out fairly recently, but very few people have made the migration for products that tend to be long-term support projects that they ship to people and then don't intend to change for a year. And so as it stands, Reversal will support basically all of the operations that exist in kind of modern Ruby that you might find in the wild. And so finally, I'm presenting Unrubby, which is my tool. And so Unrubby is kind of a few components. The first is that you get a hacked up Rubby VM. And so basically when you run, if you take this vendor's project and you replace the Ruby binary in the bundle that they give you with Unrubby, and then you run it, it'll spit out the full source to their application that's standard out when it exits, which is really neat. So it has a ton of internal hooks that we'll dig into a little bit more in a second. And then it reaches out to my fork of Reversal to actually offload decompilation. And finally, it coughs up source code, which is great. But so you might ask, why not just use Reversal, right? Like, why do I need to do all of this elaborate hooking? Like a while ago, I said that I had access to instruction sequences. I have a project that ostensibly turns instruction sequences back into source. Like, this ought to be a solved problem. This should have been done in 10 minutes. However, Reversal's mode of operation is a little bit fragile. Like I mentioned, kind of the procedure of creating a class or defining a method is just an operation on the VM. It's not internal state that's in any way separate. And so if you wanted to look through an instruction sequence and find all of the classes, you would need to just look for all the instances of defined class, which means that your decompiler needs to maintain a spectacular amount of internal state, right? Because every operation taking place in the VM before that has the potential to affect the operations afterward. And if you're not operating kind of inside of a running VM, you don't have any way to check your assumptions, right? If you get halfway through the byte stream and you say, like, I believe that all of these classes should have been created, you have no mechanism to find out whether or not you've actually done this correctly. And that's where Unrubby comes in really handy, because it hooks the behavior of the VM and not directly just kind of trying to statically reverse the bytecode. It allows me to do things like have assertions, as well as to just kind of, instead of saying, this operation will do this thing because I know how it works, it offers me a lot of power to say, actually, I'm just going to like pull it and like pull the ripcord. I'm just going to point PC at the start of these instructions and see what happens to the universe. And from that, I can tell what it does. And this is why defeating Unrubby is extremely fragile. If you do anything to try and break this, like, yes, I may have to work around the specific thing that you've done, but in essence, like, you're still ultimately calling back into the VM and you're asking it to do things. And so the fact that I'm actually co-opting the VM's specified behavior means that it's going to be difficult, if not impossible, to ever kill this technique. So when you want to dig further in, where do you actually start? So like I mentioned, Reversal claims to be able to turn an entire program back into source. And that is somewhat true in fairly contrived examples. Kind of digging through the way Reversal originally worked, it was fairly clear that the operations, or the test cases that he was passing in were just generated by YARV itself. The mode of operation was basically take Rubby source, compile it, decompile it, and then string compare the two options, which is awesome when it works, but less good when it might be a different compiler or even a compiler and then an obfuscation step generating it. So just to kind of recap a little bit, we have two layers of obfuscation to get past. The first is, what have you done to my file? Why, like, obviously a single call to loader.load that passes in a massive base64 encoded string is not obviously translatable into anything directly. And the second is that the bytecode is thoroughly, thoroughly mangled. So the first one is kind of really difficult, right? The second one. So this is an example of creating a class. So I'm calling define class with foobar. And this does what you would expect. It creates a class called foobar. But so you would naively think that if I grep through all of the disassembled bytecode and look for all the instances of define class, that will tell me where all the classes are. And that's an assumption that Reversal originally made. However, this is equivalent bytecode, which loads the constant class onto the stack and then invokes its new method, which in effect creates a brand new class and then gives it the name foobar. The result in both cases is exactly the same. I've created a brand new class. However, in the second time, there's no reference to the define class opcode. And so if this is the only technique you use for defining classes, the original implementation of Reversal would just skim through it and tell you that this code has no classes in it, which would be intuitively obviously not the case because it's working software. And so I needed to dig further into the VM to try and work out how I could kind of generally defeat this. Obviously I could write code that skims for you loading the class constant and invoking new on it, but there are dozens of ways to skin that cat, right? Like getting access to the class with a capital C is extremely easy, and there are probably like boundless ways of doing that, and any attempt to just kind of find them would be really foolish. So what I did instead was hook the behavior of the VM even further. So now I look for attempts to include a module into an object, attempts to extend a module into a namespace, attempts to define classes, and attempts to define methods. And so using this technique, it really doesn't matter how you go about performing those operations. My callbacks will be hit, and now I'll be able to look at a smaller piece of bytecode. This has a fringe benefit that now that I'm looking at smaller chunks of bytecode that are delineated by the VM, in the case where I do just get confused and not know how to reverse this, it's no longer catastrophic. It doesn't result in me misparsing the rest of the file based on a faulty assumption that I've made. And it also means that I can just back out and say, well, this method didn't decompile cleanly. I'll just give you its bytecode, and then I'll go on working on the rest of the VM. And so the patches all look like this. They're extremely simple at the C layer. All I do is get a reference to reversal. The reason for doing it this way is to give you an option for making sure that if you don't actually want to load it, you don't have to. And finally, the loaded shim is really, really nasty because the first couple times I tried to do this, reversal began trying to decompile itself in spite of the fact that it was only half loaded. This doesn't work very well. And then what you do is you start adding hooks. So in iSeekEval, this is in define method, I just start adding more and more hooks to say, hey, reversal, I have some more stuff. Why don't you have a look at this? And so it'll decompile it, build up an internal data structure that looks like this. And then before we exit, I can just dump this all back out, formatting it back as Rubby source. Now this part is actually more powerful than it seems, because if you've already written something that works like a static analysis engine, instead of having to emit the source, parse it back in so that you can analyze it, you can actually take this intermediate representation and inspect the VM itself. In this way, you kind of have additional control because you're not dependent on reversal's interpretation of the code. You actually have the original code. And so this has the final bonus of unfurling metaprogramming. In the case where someone has done something tricky, like reading the contents of a file and then using that to define a bunch of methods, if you had the original source code, you would have to read the code that reads that file and kind of infer its contents and then kind of expand that by hand. Whereas in this case, you actually get the generated code, which ultimately means that you have the highest level view of the code base. For example, if you're statically analyzing and there are dynamically generated methods, you're not going to have the option to look at those dynamically generated methods. Whereas in this instance, you actually get everything. And so Ruby classes are sort of strange. Aside from the fact that there are more ways to define them than just invoking define class like you might naively believe, there are more than one ways to define them at the VM layer. There are just simply a bunch of operations that result in a new class existing in the universe. And so the easiest thing to do is acknowledge that our hook function is idempotent and just run through class.c and hook literally everything. And so I wanted to give a demo of this. Because I'm really, really clever, I managed to leave the machine that had all of my samples on it in the US. However, I grabbed a sample. Is it possible to stop the cameras just for the duration of this demo going? So if they're doing something like trying to integrity check, you sneak in like after the integrity check before the source load, and you win. So with this said, like I now had a toy, right? And it worked in the lab. I kind of obfuscated stuff and then deobfuscated it, and the deobfuscated thing was the same as the source. But I wanted to go out and actually like break things in the wild. Like that was the whole point of building this. Like, how do you go about doing that? So Rubby is extremely dynamic. And so like, a bunch of these applications that people are shipping to the wild are a Rails application, and it follows the same Rails hierarchy. And so one thing you could do is take the entirety of Rails and just delete all the bodies. And this is reasonably easy to do. There's a gem that can parse Rubby and let you do arbitrary AST transforms on it. You can do an editor macro that just deletes everything that doesn't begin with class, def, or module. But you can actually kind of do this in a more general way and kind of hit all of the environment. So I have complicated feelings about some of the things that Rubby lets you do. I think it leads to dangerous, fragile code that's difficult to understand if you're a developer coming into the project late. You can use method missing to say, if you try to call a method and it doesn't exist, just call this method and tell me about it. Same thing with const missing for accessing constants that don't exist. You can also reopen classes and do things to them. And so what I did was, I wrote these two shims. And so what this does meaningfully is it says, if ever you try to look up a constant in the universe that doesn't exist, return a stub. And that stub, if you ever try to call a method on it that doesn't exist, it returns another stub. The impact being that if you load this into the VM before their code, it literally doesn't matter what their code depends on. It'll just kind of work for you. There is one subtle bug in this, in that occasionally you need to use module. Like there are some operations that work on modules and not objects. There is now a patch in unrubby that kind of makes it look the other way when that happens. But in the general case, kind of, if you preload this and then literally any code, their code will load well enough that you can reverse it with unrubby. So the next thing that I started getting interested in was how to do this stealthily, right? Like proprietary software nearly always has some kind of a licensing mechanism. And that licensing mechanism nearly always wants to reach out to their server. And I thought it would probably be bad if the applications that had some tie to my identity that I was bringing up in an obviously malicious VM so I could look at them were able to call home and tell them about that. I figured that would probably not be a whole lot of fun. And so the canonical solution to this is to stand up a VM on your machine. You don't give it a network interface that can talk to the outside world. You kind of poke at it locally using the console. And while this does work, it's an extremely miserable way to work on this, especially if you're doing something like developing unrubby, and so you need to push source code back into it fairly regularly. I duplicated this slide somehow. That was impressive. So, I feel like every time I've spoken to someone who does this, they do it really well for about 2 days, right? And then it's like, oh, I'll connect it to the internet for a little bit, but I'll remember to like take that NIC back down before I actually boot anything. And 2 days after that, it's like, oh, I don't think it calls home. And 2 days after that, you're just running it on your host and kind of ignoring everything, which is not great if you're going to do a lot of this, right? Like eventually, like the probability of something bad happening to you becomes like exactly 1. And so what I did instead was evidently managed to delete a slide. But what I did do is I patched all of the socket library in Rubby. So there is another environment variable that you can export called unrubby sockets. And if you export it, it'll destroy the entirety of the socket library. It'll actually make it impossible for that VM to talk to the outside world. The one exception to this is that C extensions can still create sockets. They can kind of poke the syscall directly. But if you know for a fact that there's only native Rubby code in this thing, you can kind of statically guarantee that it can't talk to the outside world. If you're super paranoid, you could also bring it up under something like sekump. So what do you actually get when you unbox unrubby? So you get a Rubby source tree, which has a bunch of patches applied to it. You get a patched version of reversal that has kind of support for modern Rubby, as well as some extra goodies for kind of decompiling in this mechanism that I feel works a lot better because it's behavioral. As well as kind of shims for some other stuff that will just make your life easier. I actually wrote a shim specifically for Rails that will kind of unpack some Rails-specific behavior and tell you things about the application, as well as that ridiculous shim that just kind of like nerfs the entire universe so that you can load more or less anything. And so like, I really want people to play with it. Part of the purpose of this, like part of the reason I was so excited about it, is because the third thing that I reversed with this, I'd literally never interacted with in any way. I sent unrubby to a friend of mine and just said like, hey, just like replace like the Ruby binary with this thing and tell me what happens. And a product that I knew literally nothing about immediately fell apart and gave him all of its source code. And so the cases where this isn't the case, like I really want to know about so I can fix them. And so if you have such a thing that you're curious about how it works, like I really encourage you to poke at it. In the event that it does explode, there are some notes in the GitHub repo for how to tell me about the bug in a way that doesn't involve sending me proprietary IP, as well as unrubby report bug, which causes it, instead of faulting, to kind of print a bunch of diagnostic information that's super useful to me. So you also get a couple of other things kind of bundled along with it. Unrubby full iseq actually makes it have a stab at parsing the full instruction sequences. This is almost useless in practice, purely because there's kind of a better one now. But if nothing else, it's kind of academically interesting to compare what it winds up with in both cases. There's also unrubby methods, which will decompile method bodies with a different decompiler that seems to be working a little bit better. And finally, YOLO, which turns on all the debug logging. I just kind of litter YOLO comments around the code, and it was only natural that eventually I made them functional. And the other thing that you can do is abuse the autoloader. So Rubby has this neat feature that says, instead of loading a class, which they believe is slow, I'm going to tell you where to find that class when you need it, right? And so in your application's initializer, all you do is say, like, when you want this class, go and load this file, which is really unfortunate because if you're unrubby, right, I bring up their application and then I kill it, and all it does is print a bunch of autoload directives, which is really sad because I didn't get to look at the code. unrubby's autoload is not very lazy. If you tell it to autoload things, it immediately tries to generate a reference to that class and reaches out to get it. So this means that even if you are looking at an application that tries to be lazy like that, you will still get the full source code. So there's kind of a few other bits and pieces associated with this. Unrubby currently targets Rubby 2.1. I would really like to support 2.2 if someone's interested in working on that. Like, first of all, I'd like to see a sample in the wild of something using it, but I think it'd be really fun. The neat thing is that the vendors give you everything you need to do this, right? Like, their loader comes with the software. It's kind of intended to work that way. But on the off chance that they are doing something like integrity checking, or they've kind of gone through and statically linked their Rubby in, so that it's not a discrete binary that you can trivially overwrite, it's pretty simple to just deal open that thing and kind of poke at it fairly directly. I would really like to build automated tooling for doing that as well. And so I get asked a lot kind of how I would defeat this thing. If I was working on defense, like, what would I do to make this not work? And bluntly, I'm not convinced that it can. Like, I kind of suspect that if you're going to write software and you want to sell it to people and like give them executable code in some form, and you don't want them to have the original source, like, using a really dynamic VM in the first place was a bad choice, right? Like, for the reasons that I mentioned earlier, the only ways to make that tenable would be to just throw away all the usefulness of the dynamic VM when you're writing the software in the first place, right? If you use useless class names, no one gets any information from knowing what the class names are, but you also make your life hell because the class names are useless. And so there are kind of a bunch of cat and mouse games that I would play. One of the first ones I would do is, at boot time, just kind of reach out to argv0 and try and see whether it looks coherent. Unfortunately, the solution for that is really obvious, right? Because I get PC control before they do. I just change argv0 to point to their Rubby and continue doing what I'm doing. The other obvious trick is to kind of attempt to use the file's properties as internal offsets, right? So that if it's not correct, then their deobfuscation layer will stop working. I'm 99% certain that someone will try to do that in the next year, and I'm really looking forward to breaking it. The best idea I came up with for like how I would plausibly defeat this technique is to shove everything into one monolithic binary and actually force someone to write an elf parser and kind of carve it up and shove it into this thing. But even then, I'm not convinced that that effort is worthwhile. So with that kind of, I really want to encourage people to go out and break stuff with it. Better still, kind of port this to another platform, right? Like all of these techniques that I've implemented for Rubby work very directly on something like Python or Node or even Erlang. Really all it takes is someone writing the same shims for those platforms. And finally, I wanted to call a couple of people out. Rich Smith for writing Pyretic and also kind of listening to me rant a little bit when I first started working on this, as well as Michael Edgar for writing the original reversal. Definitely Troopers for having me, and a bunch of people that I'm missing. So I've actually come up a little bit short. I obviously didn't pay even nearly enough attention to the sticker on my laptop that says "Speak slower, idiot." But hopefully that means we've got 10 minutes for really insightful questions. If you have questions, I can just repeat them.
So, what is the most that you can do to a VM legitimately when you're in it? Can you say reshuffle by the meaning of bytecodes?
Yeah, so the question was, from within the VM, like, what is the most aggressive? Do you mean from the perspective of someone trying to develop the obfuscation engine? Yeah, so the question is, kind of as someone trying to develop this obfuscation engine, how far could I go trying to kind of mangle the VM in such a way that this would stop working? You absolutely could, in the sense that you could do something like shuffle a bunch of the bytecode names around, right? Like, and in order to do that, all you would have to do is kind of remap chunks of the text segment writable, kind of like fiddle around with the constants at boot time, and then kind of put everything back before you pull the ripcord. I've definitely considered that you could do this. I think the huge problem with doing it is that for something kind of naive like that, it's actually going to be incredibly simple to work out what's gone wrong, right? Like, because the VM kind of operates in a fairly, I guess, pure environment in which it doesn't have a lot in the way of side effects, you can basically go through in a vanilla VM, kind of exercise every opcode and see what change that has on the universe, and then try it in their VM and kind of just let Reversal map it up for you. I think kind of more generally, you're actually going to be better off kind of introducing your own opcodes and kind of occasionally invoking them to try and trip something else up. But the neat thing is that because of the way that Rubby bytecode works, there's kind of a ton of instructions that exist only for instrumentation purposes. And unless you've actually come up with something kind of interesting for that side effect to do, you can get really far just throwing all the instructions you don't know anything about on the floor and kind of working backwards from things breaking. Are there any other questions?
Okay, more questions? Please, can you
I
go to the
can
mic?
repeat it again, or
No.
whatever.
At least one mic is working, and
Certainly.
now mine is too.
Thanks. So philosophical question, given that unrubby basically makes any form of bytecode obfuscation pretty ineffective, if you're a software vendor, does it still make sense to put the engineering effort into attempting to obfuscate in the first place, or just bite the bullet and accept that your customers will see your source code?
I mean, at the risk of kind of giving a cop-out answer, I think it depends a little bit on your threat model, right? Like, I don't think do I care about my customers having the full source is actually kind of black and white. I mean, personally, I believe that like I should have the right to work out how the things that I interact with work. And where that stands on the scale of like, should you be entitled to make that process extremely difficult for me? I'm not exactly sure. I really suspect that no one's going to invest strong effort into this for anything kind of critical, right? Like if your goal is to dissuade people from doing this, then the existence of this tool will probably work, although like there's still kind of the assumption that people who want to look at it actually know that this exists. I don't see them going out of business anytime soon, but I also can't imagine new players getting into the game.
Hey, wanted to bring up the question after the talk, but since there are no other questions, did you look at GitHub Enterprise? It has been a couple of years since I downloaded it, but back then they were using Rubby or some sort of fork.
Yeah, absolutely. So I'm a little unwilling to go into like too many specifics about GitHub Enterprise specifically. I will say that kind of one of the engines that I didn't really look at the machinery inside of, but did test the technique on, it definitely works really well on that. Having had a quick look at it, it does appear that they went down the route of building their own obfuscator, which is kind of an interesting choice, right? Like when you're a software company, you only have so many man hours to spend, and the assertion that you're going to do a better job of building this than someone whose kind of day job it is to do this is not obviously true.
I think a couple of years back they actually used Rubby or some fork of it, but it might be the case that they switched to their
so they're
own
absolutely still a
tool
Ruby
now.
shop. I think at this point, from a business perspective, like they're so far committed that the main application will never stop being written in Rubby. GitHub Enterprise itself, when it's distributed, is packed by their own encoder. Instead of taking an off-the-shelf project, they kind of like wrote their own thing to do it.
Yeah, but what I meant was that in the past, I think they used the Rubby or some tool, obfuscation tool that was open, not their own.
Interesting.
Their own thing. I think like 3 or 4 years ago.
Oh, fascinating.
If I remember exactly, I can maybe look it up.
I looked at it fairly recently, and they're definitely using something that's home cooked. It does not stand up to unrubby.
Okay, more questions? Sorry? Wait.
So what's the biggest Ruby kind of piece of infrastructure, do you think?
That's kind of a good question. GitHub is honestly a pretty plausible candidate at this point. Kind of, if nothing else, if you've ever run an instance of GitHub Enterprise, you know how many pieces it has because they break individually and tell you when they're broken, and you just get a lot of discrete broken things. In terms of the biggest project that exists, I don't even have a great answer. In terms of lines of code, Metasploit, GitHub Enterprise, I think Tedium used to be written in Rubby. I don't have a great sense of what kind of the biggest things are. I guess the flip side is that kind of because this works so incrementally, the kind of net size isn't tremendously important.
Okay, more questions? Wait.
Yeah, maybe it's more a meta question. There is this stupid law that you must not overcome protection mechanisms in a product. So, but then on the other hand, you could argue if the protection was not effective in the first place, then there is no issue. So, do you have any opinion of the legal status of such a tool?
Yeah, I mean, I don't. I mean, I'm pretty confident that like the actual like exact wording of the law is immaterial. Is why I kind of intentionally made sure that I wasn't making it public, like who exactly I tried it on, even though you can make some pretty obvious guesses. In terms of whether or not what I'm doing is illegal, I am genuinely sort of fascinated in getting a proper legal opinion, because I would argue that I never reverse engineered their software. Just before the first time I spoke about this, Oracle went like full Oracle and suggested that like you shouldn't reverse engineer Oracle things because they got this, which is fairly obviously not the case. In fact, D. Litchfield just went on another rampage yesterday. The actual question, kind of how legal is this, I bluntly don't really have any idea. I'm hoping to not find out by getting sued, but I would intuit that it's probably not crazy legal. Sergey points out that I might be able to claim the interoperability clause. Again, I'm kind of hoping to not actually have to test this in court.
So not a question, but a comment on GitHub Enterprise. There was a public blog post a few months ago about somebody who had looked at their obfuscator and took it apart, and there was a string comment inside that said, "We know that you can break this obfuscation really easily. We just don't want sysadmins running GitHub Enterprise to set variables and break our code."
Yeah.
So it kind of goes back to your threat model conversation earlier as well.
Exactly. I guess kind of as an aside, I actually know 3 discrete people exploiting the same local root vulnerability in GitHub Enterprise so they can make backups. So there's kind of like an incentive to keep that bug alive just so that you can back up your GitHub Enterprise deploy. Cool, so I think I've just about run over, but if you do have questions or questions that you're unwilling to ask in public, feel free to grab me. I'm always super happy to talk about this.
Richard, thank you very much.
Thank you.